Question 8. The diagram shows a right-angled isosceles triangle XYZ, which circumscribes a square PQRS. So XYZ is a right-angled triangle, and it's an isosceles, so XY and XZ are the same length. Circumscribed means that the vertices of the square touch the lines, the edges of the triangle. We're told that the whole area of XYZ, the whole area inside that triangle is X. Now, this is a spotting exercise. Normally with a geometry question, we're spotting isosceles triangles. This time we're actually spotting congruent triangles. That means the same triangles. From this, we know that this length and this length must be the same. We know that this length and this length and this length and this length must be the same. And if we've got this length being the same, we've got a lot of right angles in here. And if we split this one in half, then what we've got, wait a minute, so we've got this length being the same as this one, and this length being the same as this one. But if we split this down here so that we've got right angles, we end up with another right isosceles, a triangle, so that this length and this length are the same, this length, and we can do the same with this one, this one, this one, and this one are all the same length. And we can do exactly the same in the middle of the square as well, where we've got isosceles triangles in here, and they are all exactly the same length. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 congruent triangles. We've got 9 triangles equals an area of X. And so the square is 4 of those triangles. This square in here is 4 of those triangles. And therefore the area of those 4 triangles is 4 triangles divided by 9. This is the area, and that is 8.